going to do a little difference quotient review. The first thing that we need to do here is just remind everybody of the formula for difference quotient. The difference quotient formula is a huge fraction with an h underneath. The numerator has two functions. The first one is f of x plus h, and then minus the little f of x. Okay? Whenever you're doing your work for difference quotient, I highly recommend doing this in two steps. So the first thing we're going to calculate is f of x plus h. That's usually really large, and that makes a lot of our work later easier. I'm going to separate my paper clearly so that this work stops, and the difference quotient work is going to start down here, difference quotient. Okay, let's take a look at this f of x. This one only has one place for input, so it's going to be a little small. 4 times the input has to get squared, minus 9. Okay, f says 4 times your input squared minus 9. I can do that. I could do 4 times my input squared minus 9. That's what f says to do. But this is f of x plus h. When the input is a quantity, that's going to go into the input spot, and we're going to have to FOIL that out. So the first thing I'll do is write down, I'll write x plus h times x plus h, and I just show people one more time where we get this from. You certainly don't have to do that if you're familiar with this answer already. When you do the outers and the inners, you get plus 2xh plus h squared, close it up, minus 9. And it's time to distribute the 4. 4x squared plus 8xh plus 4h squared minus 9. So that is the calculation for f of x plus h. Now when you do the difference quotient, it says to put f of x plus h in the numerator. So I'm going to write all that work down here in my difference quotient line. Okay. Then I have to subtract, I always use a red pen for this. I have to subtract f of x. So here's f of x. I need to subtract that. I need to subtract both of the terms. I will subtract the 4x squared, because that's the f of x, and then I have to subtract the negative 9, which becomes a positive 9. And don't forget, it's all over h. You must write the fraction with the h every line. Remember what happens if you're doing it right. 4x squared and negative 4x squared, things are going to cancel, plus minus 9. Okay, all of the f of x terms are going to cancel out. If you're doing it right, that will happen. So now we have 8xh plus 4h squared all over h. Who remembers what the next step is? Yes, since they all have a lot of h's, you're always going to factor an h out. One h factors out from both the terms. And that h that you factor out will always end up canceling away. So the difference quotient for this function is 8x plus 4h. Difference quotient. Very important that you know how to do this, because you're going to use this technique a lot next year when you go to calculus. And we do a lot of function notation in this class. Okay, we're going to be focusing today on domain of functions. Again, a very important topic. You're going to have a lot of homework this chapter on domains. Domain means the x values. The x values that are allowed into a function. Into a function. Domain is what goes in. Does anybody know what it's called for the values that come out? Range. X goes in, y comes out. Domain goes in, range comes out. All right, there's only 3 cases in the whole world you have to memorize. 3 cases. There's only 3 problems that you might face. Okay, the first one is radicals. If you have an expression under the radical, okay, there's something that this expression does not like. Under radicals, you're not allowed to use negatives. No negatives. So then you take the expression, whatever that is, You take the expression and you say greater than or equal to 0. Can we do 0? I think so. Let's check and see. If I take my calculator, the square root of 0 is, 0. Can I square root a negative 4? Oh, you get imaginaries, so it's not going to work. Okay. The second case is denominators. You know what the problem with denominators is? Denominators, they do not like 0. You cannot have a 0 down there. So you take your expression, you take the algebraic expression, whatever it is, and you say, expression, you are not allowed to equal a 0. Now, the third case is really just a combination of these two. If you have the expression in the denominator, then no 0. But if he's in the radical down there, okay, then you're not allowed to be negative. No 0 or no negatives. So you kind of have to consider both of these. You're not allowed to be 0. You're not allowed to be negative. The only thing you can be is positive. So you say expression, you have to be greater than 0. You have to be positive in order to work in that problem. After you make these problems, then solve. So then you just do your algebra 1. Okay, I'm going to look at some functions here and walk you through how to figure out their domains. Okay, question A. Look at this function here. It's going to be a parabola. Does this function have any radicals or any denominators? No. No. So the domain for this one is all reals. Any real number. Really? You tell me I could put a positive number in there? Sure. Can you calculate with a negative number? Absolutely. How about some decimals, fractions, 0? Everything works in that. There's another way you could write this. If you don't like writing out those two words because it's so long, you can write double bar R. That means all reals. A lot of people will do double bar R for domain. Okay. The next one is a little more fun because I see an expression in the denominator. So just try to think to yourself, what's wrong with denominators? You can't have a 0 down there. So I'm going to say x squared minus 4. That expression cannot equal 0. Okay, so we're looking at this rule right here. Expression, you're not allowed to equal 0 because you're from the bottom. There's a couple ways we can solve this. If I decide to go with square roots, you cannot equal a 4. Can you square root with a not equal sign? The answer is yes. You can do whatever you want to a not equal sign that you can do to an equal sign. So we can go ahead and square root this. X cannot equal plus or minus 2. Now, how are we going to write our answer? We're going to say the domain is all real numbers in the world. Any number you want to plug in, except, okay, draw a comma, except x cannot be plus or minus 2. You can use any real number in the world, except not plus or minus 2. All right, problem C. I see a radical. And the problem with radicals, they don't like negatives. They want the expression to be 0 or positives. So first, let's write down the expression. This is the stuff under the radical. The expression from the radical has to be greater than or equal to 0. So for the first assignment, you might be looking at these boxes and trying to help you write your problem. After you make the algebraic problem, then you solve it. I'm going to go ahead and subtract 4, switch sides, switch signs, divide both sides by negative 3. X is, what? What's happening here? I'm dividing by a negative. That's right, we got to flip that sign. Less than or equal to 4/3. Now, we're not going to say all reals, but then all the ones less than 4/3. So for domain, you just say it like that. I'm not going to say all the real numbers in the world except half of them. When it's except a couple things, then you say all reals except just these two. If it's an inequality, you just write it like that. All numbers less than 4/3 will work in that expression. Really? Is that true? Let's pick a number less than 4/3. I think x equals 1. Will that work? Well, let's try it. Let's try plugging 1 into the expression. The square root of 4 minus 3 times 1 is the square root of 4 minus 3, which is the square root of 1. Oh, that works, because radical 1 is 1. Yep, that doesn't make a negative under the radical. All right, let's keep going. What if we have a problem where there is a radical in the denominator? The expression is in the denominator, so I know that that expression cannot be 0, and it better not be negative. If you can't be negative and you can't be 0, well, then I guess I'll be positive, greater than 0. So you should be looking at box 3 up here, and that is the equation that you make to solve. This one's nice and easy. We'll just move the 4 over. X is greater than negative 4, and that's exactly how we'll say the domain. Greater than negative 4. Okay, E. Oh, it's kind of tricky. I don't see any radicals. I don't see any denominators. So don't spend too much of your life trying to figure this out. What kind of numbers can go in here? All real numbers can go into that one. If you don't see a radical or a denominator, then don't do any work. Here's a little tiny denominator. The expression is so small, it's just x. X cannot be a 0 down there. So what's the domain? All reals except the number 0. We can put 5, 6, 7 in. We could put negative 5, 6. We just cannot put a 0 in. Okay, letter G. I see some stuff in the numerator, but that is not one of our rules. The expression from the denominator, x squared plus 5. Since it's from the denominator, you want to say not equal to 0. I think I will square root this, move it over. You get a negative, and what number are we getting? I'm not getting any number. So I'm trying to figure out what x can't be, and there's no value. So what number are we going to put in for the domain? You can't say no solution. Nothing goes into this problem? Well, yeah, there's lots of things that will work. I'm trying to find the restriction, and there is no restriction. No restriction? Well, then that means all reals can go in. Are you sure? If I put a negative into the bottom, is that going to be okay? A negative squared makes positive plus 5. What if I put a 0 in? 0 plus 5 makes a 5. Any number will work in that denominator. Okay, letter M. I see an expression under the radical. X minus 16 has to be greater than or equal to 0. X has to be greater than or equal to 16. You don't say all reals, you just say all x's that are more than or equal to 16. Okay, this one here, I see an expression in the denominator. X squared minus 16, so look up at the top and make an algebra problem here for me. So we got x squared minus 16 cannot equal a 0. You can square root it, or if you'd like, you could factor. I haven't done any factoring today, so I think I'm in the mood for that. X plus 4, x minus 4 cannot equal 0. It's a little different when it's not. Instead of saying x equals negative 4, you say not equal to negative 4, and x cannot equal a positive 4. Now don't forget, this is domain, so you want to say the domain is all real numbers except those two. You can plug any other value into the function and it would work. Alright, let's do some more till we really get good at this. see an expression under a radical sign. 9 minus x has to be greater than or equal to 0. We don't want any negatives under there. Let's switch sides and switch signs with the 9. And so x, if I divide by -1, has to be less than or equal to a 9. There's the domain. Domain for letter K. I don't see any radicals. I don't see any denominators. Who knows the domain? Very nice. All reals. Good job. Letter L. The numerator is okay. We don't ever do anything with them. Any number can go on top of a fraction. It's when there's a denominator. Okay, remember what's wrong with denominators? I showed you this one day in class, NO. You don't want to equal 0 down there. So let's say x minus 14. We don't want him to be a 0. So x cannot equal 14. Okay, now how do you write this though? We want to clean this up a little bit. So we want to say the domain is all reals except, if you don't write that little d, that's okay, because the directions say find domain. But you have to say all reals are allowed in except that one number. 13.5 is okay, but not 14. All right, let's keep going. Ooh, letter M has a nice denominator. Look at that. A quadratic 2x squared plus 7x minus 15. Remember, when you're in the bottom, you can not be what? Cannot be a 0. How are we going to solve that? I think we're going to have to practice some factoring skills. All right, what I'd like you to do is get this thing factored however you need to, M8 table, whatever. Go ahead and pause the video until you get this factored. Did you do it? Okay, let's see what you got. 2x minus 3 times x plus 5. I think that's right. Outers make 10x minus 3x. Make positive that I got it. Okay, and now we're going to go ahead and split these up right here. So the domain is all reals except x cannot equal. Do you know what the answer for this is going to be? If you move the 3 over, it's going to be 3 halves. And x cannot equal -5. So there's lots of values you can plug into this function. All reals except those two. Okay, a couple more. I see an expression, 23 minus x under a radical. You know what the problem is with radicals? They don't like negatives. 0 is okay. They don't like negatives. So I can equal 0 or I have to be greater. Positive or 0 under a radical. Switch sides, switch signs with the 23. Divide by negative. You're going to get less than or equal to 23. And that's exactly how you write it. You don't have to say all reals because you're saying half the numbers in the world. 23 and all the numbers less than him. Okay. Oh, what happens when there's an absolute value? What's wrong with them? Do absolute values like negatives? Yeah, they'll work. Well, they accept positives and 0. So what numbers can you not put in there? You could put all numbers in the world. Remember, there's only 3 things we're looking out for. If you happen to spot a radical or a denominator, then you have to do some work. Letter P. Letter P, I see a denominator. That's a problem. Denominators do not like to be equal to a 0. You could factor this by sopping it up. I think in this case it might be easiest to just solve by cubed rooting. If you cubed root the left and you cubed root the right, cancel, cancel. X cannot equal, is it plus or minus 2? It's just the positive 2. Positive 8, positive 2. So all reals except not a 2. Okay, how about the domain for Q? What's wrong with this? Should we try factor by grouping? No, we're not factoring, we're trying to see what the restrictions are. The domain, I don't see a denominator or a radical. The domain is all reals. Don't spend too much time on that. For letter R, I see an expression in the denominator and in a radical. So it can't be negative because of the radical, and it can't be 0. So that expression needs to be positive. How do you say positive? Greater than 0. X has to be greater than 16. Okay? Please study those 3 rules for domain, and we're going to do some problems tomorrow. Thanks.